Hello. Hello. Hola. You know, Mr. Bugs hasn't been on camera for a while, so let's put Mr. Bugs on camera. Hi, Mr. Bugs. How you doing this morning? How you doing, Mr. Bugs? Can I get a num-num? Num-num. 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 Oh, thank you. Waiting for a couple more viewers here. Where is everybody? All right, I guess no one wants to show up this morning, so I'm just going to start. Good morning. So, we are going to have, let's see, the midterm was due yesterday. We're going to have a separate lesson for HL and for SL today. So back to the usual way things go. So for the SL lesson, I'm going to be teaching you about graphics. Okay, and for the HL lesson, we are going to learn some different sorting algorithms. Okay, which is on the IB exam. So I'm going to get started by. There's a little doggy battle happening behind me. I can't pay attention to you right now. Yeah, you got to entertain yourself. So let me share my screen and we will get started. Okay, so I've got just a basic program here. All right, and let me zoom in actually. Make this more viewable for you. Okay, so this lesson is necessarily going to have some stuff in it that we don't know about yet. That's okay. I'm going to give you all of this code for you to do the assignment. Okay. So I have an object called a J-frame, which is basically a window. And it says, I called it window. So J-frame window equals new J-frame graphics practice. So this string right here is going to be the title that's at the top of the window. Okay. So this is create a window object titled or I guess with graphics practice at the top. Okay? And then what we're going to do is we are going to set the bounds of the window. So there's a set bounds function. And these are just the initial bounds because you know the window you can resize it all you want. But this is telling us the starting location. So let me show you how that works. So here's my document camera. So let's suppose that this is the screen of your computer. Okay. Then they put the origin right here. So this is the origin. This is the X direction, and a little bit different from when you're doing your coordinates in math class. The Y direction actually increases downward, okay? And it's measured in pixels, okay? So that, in that set, I can't remember what the method was called. What was it called? Set bounds. In that set bounds method, it said set bounds 100, 100, 300, 200. Okay, that was the declaration that was made. So these are the initial X coordinate and the initial Y coordinate of the upper left-hand corner of the window. So what this says is create a window that is over 100 pixels and down 100 pixels. Okay, so that's going to be the top left corner of where the window appears. Okay, so all these are measured in pixels. So it might look different on different screens because they have different pixel sizes. Okay, this is the width of the window in pixels. Okay, so this is 100 pixels. This is 100 pixels. This width is going to be 300 pixels. And then the height is going to be 200 pixels. So the window is going to look something like this. All right. So if I wanted to know what is the coordinate of this corner of the window, for example, I can see that it would go over 100 pixels plus 300 pixels. So that would be 400, comma, and then it goes down 100 pixels and then 200 pixels. So that would be the coordinates 400, 300. All right. So going back to this. So this creates, or it determines where the window appears, how big it is. And that's just initially, okay? Then we have to say what is going to happen when someone closes the window. So set default close operation. And so we have exit on close. So that means that the program is just going to end. So the program keeps running until someone closes the window. And so then what I'm going to do is I'm going to put what's called a JPanel in, okay, and called canvas. And it's a new graphics practice object, which I define over here. So we're going to get to that next, okay? Then I'm going to set the, so basically the J-frame is just the window with nothing in it. The J-panel is what goes inside the window, okay? So J-frame is the window. J-panel is what is inside the window. And so the thing that's inside the window, which is called canvas, I want to set the background color to white. Okay. And then there's this little thing, window.getContentPane.add canvas. So this, notice how this declaration in lines 10 and 11 has nothing to do with the window. So I need to put this panel into the window. Okay, so this puts the panel into the window. All right. And then we just make it visible. All right. So this is basically going to display, and we're going to talk more about GUIs in a couple weeks, but our first objective is just to display a window, okay, and then put something in the window. So this is really what we're going to mess around with. Okay, this is going to be the same for everyone's program. But what I have over here is the graphic practice class. Okay, and so the graphic practice class extends JPanel, so it's inheriting from JPanel. Okay, and one of the methods that JPanel has is called paint component. Okay, so what we're doing here is we are overriding the paint component method of the JPanel class. And that's all we're doing. Okay. So the paint component, so see how all I have in this class is just the paint component method. Everything else is going to be exactly the same as JPanel. Okay. So this is all you're going to be messing with. You're only going to be messing with the paint component, method. So what do I have here? I do super.paintComponent. By the way, paint component accepts a graphics object G. So the first thing you do is you call the super, so JPanel's version of paint component, and then we're going to do more. Okay. I don't need this line. I don't need this line right now. So notice how I have G.setColor blue. So that means I'm going to make a blue graphic. Okay. And then I have, so this means make a blue graphic. And then I have G.fillOval. So make an oval whose upper left-hand corner is at 0, 0. Okay, so we can see 0, 0. Has width 150 pixels, has height 150 pixels. Okay. So let's see how that works. So I'm going to compile the program. I'm not sure if I have to. I'll compile this one too. Then I'll run it. And we can see that this window pops up. The window is called Graphics Practice. You can see there's a white background within the window. You can see its width is 300 pixels. Its height is 200 pixels. And notice how, because I set the width of my oval equal to the 150 pixels, and the window itself is 300 pixels, we can see that the oval goes halfway across the window, okay? And we can see basically the way graphics works is they're inscribed within a rectangle. So even though I'm drawing a what am I trying to say here? A circle. When I define the coordinates of the circle, it's the coordinates of the upper left-hand corner of the inscribed rectangle. So if I inscribe this circle within a rectangle, its upper left-hand corner is in the at coordinates 0, 0 within this window. Okay? So I can resize the window all I want, and it stays the same. I can move it around. Okay? Then once I hit X, the program ends down here. All right? So let's mess with this a little bit. What could I change? Well, maybe I want to move where the oval begins. Okay? So in that case, what if I change this X coordinate to, say, 50, and I change the Y coordinate to, say, 100? So what that's going to do is it's going to shift the oval over 50 pixels and down 100 pixels, okay? Maybe I can change the color. So I can make it red. And then maybe I will change the width of it to, I'll make it smaller, so only 75 pixels. And I'll make the height maybe 100 pixels. Okay? So let's compile that. Let's see what happens. I think I need to compile it from here. All right. So you can see that it's in a different location to begin with. It's yeah. So you can mess around with that. Now I wanted to show you the graphics class. So here's the documentation for the graphics class, and it has a lot of different methods, okay? So you can draw, and we're going to basically go through these different methods in the coming week or two. And so I use the draw oval, okay? But there's also methods like draw polygon, draw rectangle, draw all these different draw methods. You can do text, you can draw arcs, you can so there's a ton of stuff here, and you can just kind of play around with it to try and draw stuff is basically what you guys are going to do in your assignments, is just play around with it, because it's pretty easy to figure out. It's just you got to play around with it. Going back to my program here, I just wanted to show you a couple of methods. One method is called getWidth, and that is going to, this method will get the current width of the window, okay? And this is going to get the current height of the window, okay? So what if I wanted to make a fill oval? What if I'm going to put it at 0, 0 again. Okay. And then what if I wanted to make this oval always take up maybe 75% of the window? So what I could do is I could say 0.75 times the width. Okay, so that's saying create an oval that has a width that's 75% of the width of the window. And then the height is going to be 0.75 times the height. Okay. These are, of course, pixels are measured in, integers. So I got to cast these as integers, I think. So I cast them as ints. And let's compile it. Okay, so that works. And now let's run it. Where did it go? What did I do? Maybe I don't cast it as an int. Let's try that. Okay, it says it wants an int. Okay, so I'll compile this. Compile this. Run it. Run it. Where's my window? I'm not sure why it is showing a I don't know. I'm sure someone can see what my error is, but I'm not seeing it right off the top of my head. What if I just make this width? Just make this height. See what happens. I find that the best thing is to just kind of play around with it. Let's try this. Close that. Oh, there we go. Okay, so you can see that I have it set so that the width of the oval is the full width of the window, and the height is the full height. So even as the size of the window changes, I have it set so that it's always going to be the same size as the window. Okay, so that's another thing you can do. Oops. I think I started the program like several different times, and then now I have to go through all of them. All right. So that's my little introduction to graphics. So I'm going to give you the snippets of code. And so you're just going to type into the paint component method what you want to display in the window. Now, if you have your textbook, I'm going to recommend that I think the documentation, for me personally, because I like a really concise information, the documentation itself is better than the textbook for me. But if you are just like completely lost by what I just did, there's a chapter in your textbook called Graphics. It's chapter 15. I actually think it's a virtual chapter. Like this textbook has a web page, and some of the chapters are on the web, not in the book. So this might be one of the chapters. I can't remember, but it might be one of the chapters that is in the on the web instead of in the book. Okay, so check out chapter 15 if you're completely lost. That's basically what we're going to be doing for the next week and a half or so. All right. So that's my SL lesson. If you're an SL, you can tune out and watch and start working on the lesson and on the homework, excuse me, or you can watch this. Okay, so this is for HL, and maybe I'll just turn the page over for HL. So HL, we are going to talk about, start talking about something called a sorting algorithm. Okay? So sorting algorithms. Which is something that is used a lot in computer science. Okay? And so basically what we want to do is we want to take an array of ints, and then we want to put it in increasing order. Okay? As quickly as possible. So there are a ton of different sorting algorithms. You can look them up online, and over the next week and a half, we're going to go over a number of them. And so what I'm going to be having you do is implement each of these sorting algorithms, and then you are going to use that the get current time in milliseconds, and you're going to see how long it takes to sort the array. And so we're going to compare these different algorithms and see which ones are fast and which ones are slow. Okay, so that's the idea. So your assignments are going to be basically the same each day, but you're implementing a different sorting algorithm. You could also compare the times between students. You know, maybe one person had an extra line of code that the computer is running, and then that makes their sorting algorithm just a little bit smaller, or a little bit slower, excuse me. Anyways, the sorting algorithm that we are going to talk about today is something called insertion sort. Okay, so I'm going to have an array of 5 numbers. Okay, that, and let's make the numbers 10, 7, 4, 8, 5. Okay, so the first thing you're going to do is we're going to start. So we want to sort these. So obviously the sorted array is 4, 5, 7, 8, 10. Okay, but here's how insertion sort works. We're going to compare the first 2 numbers. Okay, and I can see that 7 is less than 10. So what I'm going to do is I'm going to swap them. So you swap them. Okay. All right. So I started out with the second element of the array, and I inserted it in front of the first element of the array. Okay. Now I'm going to go to the third element of the array. Okay. All right. And I'm going to compare it to 10. And I can see that 4 should go in front of 10. All right. So I'm going to swap them. Okay. Then I see that now what I'm going to do is I'm going to compare the 4 to the 7. And I can see that 4 is less than 7, so it should go in front of 7. So I swap it. Okay? And so now it is at the front. Okay? So notice how the first 3 are sorted. So now I'm going to put my attention to the 4th element in the array. Okay? If I look at the 4th element, I compare it to 10, and I can see that 8 is less than 10. Okay, so it should go in front of 10. So I'm going to swap them. Okay. And then I compare 8 to 7, and I can see that 8 is actually greater than 7. So this one doesn't need to be moved anymore. It's in the right spot. Okay. So now I put my attention on the last element of the array, and I compare 5 to 10. 5 is less than 10, so I swap them. 5 is less than 8, so I swap them. 5 is less than 7, so I swap them. And 5 is not less than 4, so I leave it. And now I'm sorted. Okay? And so this algorithm is called insertion sort. Okay? So let me just kind of write it out in words what we're doing. Okay? So what we're going to do is we're going to start off by sorting the first 2 elements. Okay? Then what we're going to do is we're going to sort the first 3 elements. Okay? By dropping the 3rd element into place. So we drop it into place by swapping it down the line. Okay, so we swap it down the line until it falls into place. Then we sort the first 4. So we take the 4th element and we drop it into place. Then we sort the first 5 elements. Okay? And you just keep doing that. So notice how in whenever you sort the first 5 elements, you take the last one and you just drop it into place, because the first 4 have already been sorted. So all we have to do is put the 5th one into place. So we do that by just swapping it. And you keep doing that until you get to the end of the array. Okay, however long your array is. So that is called insertion sort. Now this is not a particularly fast sorting algorithm. Why is it? It's because we have to basically repeatedly go through the array. So it's like we go through the array, and we go through the array again, we go through the array again, we go through the array again. So we have to go through the array for each element of the array, right? We go through the entire array for 7, we go through the entire array for 4, we go through the entire array for 8, we go through the entire array for 5. So you keep going through the entire array over and over again. And so for that reason, it's not very fast. But it is an easy enough algorithm, so it's a good place to start. Okay? So my HL students, you guys are going to actually implement this algorithm and see how long it takes for a random array. And yeah, so that's my lesson for today, and I will see you